section 7.2, we're still dealing with linear systems with two variables, so we're talking in terms of x and y. I'm going to skip the intro for today because it's talking about the substitution and the graphing that we just did yesterday. But if you feel like you want to verify that what you have done is okay, please feel free and do the intro. We're going to actually do it using elimination in a minute. But today we are talking about elimination. And so I'm going to walk through this one more time. And again, this should be a review section. Our first step is to get the coefficients of either x or y. And it doesn't matter. The same, except they want one to be positive and one to be negative. Okay? And you can choose to do that. Please do not multiply by decimals or fractions. When you do this multiplication, you want to multiply by whole numbers. And that's the one thing that I found we still have some issue with. Okay, once your equations have the same number, same coefficient, one's positive, one's negative, then we're going to add the two equations together, and that's going to eliminate one of the variables. After that, I'm going to use that phrase again. We're going to back substitute. All it means is plug in. But we're going to back substitute the value that we got into one of the original equations. And again, please go back to the original just to make sure that we've done everything correctly. And last but not least, you always should make sure that you check your answer and verify that it works in both equations. Okay? Now I'm going to go to the intro question, and they gave you this question in the intro. They said if you have 3x minus 4y equals negative 8, and 5x plus 4y equals 40, can you solve this? One of the things that I do in elimination, just to verify that I have the coefficients be opposites, is I circle where my opposites are. So if you look in this case, you have a negative 4y and a positive 4y. And we said once the coefficients are opposites, you're going to add these straight down. 3x plus 5x is 8x. These will cancel. Negative 8 and 40 is 32. So when I divide by 8, x then is 4. Okay, so we've just done numbers 1 and 2. I'm going to take the value and I'm going to plug it in. And I'm just going to use the second equation because they're all positives. But if I take 5 times 4 plus 4y has to equal 40. Well, 5 times 4 is 20. So I'm going to subtract 20 on either side. 4y equals 20. When I divide by 4, y equals 5. Now, people have asked me, do I really have to show all of this work? And the answer is absolutely yes. We need to make sure that we see even little mathematical errors that you might make. And so by showing all your work, that does help. Now, what we're saying is we have this solution. And again, our solution is always a point of intersection for 5. Now, I want to verify. If I put this in, 3 times 4 is 12, minus, I apologize for that, 3 times 4 is 12, minus 20, do you get negative 8? The answer is yes. And so this is my solution. I don't have to check it in the second one because I used the second one to get my answer, but this is kind of what we're looking at. Now let's go through one example together where we need to get the coefficients the same. If you look at example 1, I personally always make my x's the same. So I have a 3 and a negative 2, which means I'm going to multiply the top equation by 2 and the bottom equation only by a positive 3 because I already have the negative there. And if I do that, I get 6x plus 22y equals 8. And negative 6x minus 15y equals 27. Okay, once I have my opposites, and I circle my opposites, I'm going to add them straight down. 27 minus 15 is 12y. 8 plus 27. Let me try my addition again. I apologize. Let's look at this again. 22 minus 15 is 7y. And 8 and 27 is 35. When I divide by 7, y equals 5. Apologize for that mathematical error. All right, let's plug it into one of our originals. I'm going to plug it into the top one. So 3x plus 11 times 5 has to equal 4. If I subtract 55, 3x equals negative 51. And if I divide by 3, x is negative 17. Okay? What that tells me is my solution is the point, and be careful because we did them in opposite order, negative 17, positive 5. Again, sorry for the interruption. That won't happen the rest of the video. And so you'll notice in each of these cases, the solution was a single point, which means these two lines intersect at one point. What it says is these two lines are intersecting. And what we're going to start asking you to do is classify the system. We did this in Algebra 2, but let's get us back in there. Because there is a solution, at least one solution, we say that our system is consistent. And basically, you're going to define it as either consistent or inconsistent. You got a solution or you didn't. But if you have a solution, you have to talk about how many. Because there's exactly one solution, we have to say our system is independent. Now, people ask, can I just say independent? The answer is no. When we classify these two systems, you have to give me both terms. The fact that it is consistent and independent. And so we want to see both. So just keep that in mind as you're going through. Okay? Now, we're going to do a couple other examples. So let's flip the page. I'm going to give one for you guys to check, but for the most part, we're going to go through majority of this. So let's flip to the back. I'm going to move this up a little bit. Let's do the first one. So you've got 6x, negative 6x minus 4y is negative 14, 3x plus 2y is 7. I'm going to, again, try to get my x's to be the same, and the only thing I have to do in this situation is multiply by 2. So negative 6x minus 4y equals negative 14. And if I multiply the bottom one by 2, I get a positive 6x, positive 4y, and a positive 14. Now, this is an opposite, but this is an opposite, and this is an opposite as well. And so what you end up getting is 0 equals 0. In Algebra 2, we would have said there are infinitely many solutions. Okay? What that means is that the two lines are exactly the same line. It means that because there is at least one solution, in this case there are infinitely many, we said it was consistent. But because we actually don't have just one solution, we have infinitely many, we say it's dependent. Now, I did say to you that in Algebra 2, we would have just said to us infinitely many solutions. However, in pre-calc, we want to find a way to give a solution. And I want to be able to say, well, if x is 1, then y would be this. And if x is 7, y would be this. And so we have a method for getting what we call a general solution. So here's what we're going to do. We're going to let x equal a. We're going to call it some other random variable, and a seems to be what every pre-calc book that I've ever used has used. And what we're going to do is if I know that x is a, I'm going to give you a general solution. Okay? And so my general solution will be the point a, comma, something. And I need to find what y is if x is a. So I'm going to take a and I'm going to plug it into one of my equations. I'm using the second one because they're all positive. So I'm going to put in an a. 3a plus 2y equals 7, and I'm going to solve for y. So I'm going to subtract 3a. 2y equals negative 3a plus 7, and I divide each quantity by 2. Now if I do that, I now get that y is negative 3 halves a plus 7 halves. And this is the second part then. These are the two parts of my solution. So x is a, y is negative 3 halves a plus 7 halves. And again, the reason is now I can say to you, okay, well, what is my solution if x is 14? And you can now plug in a 14 and tell me what the y value will be off this general solution. And so in pre-calc, if you see infinitely many, you are not done. You've got to give me a general solution. So kind of keep that in mind. That is the one difference from Algebra 2. Let's take a look at number 3. We've seen one solution. We've seen infinitely many solutions. We can probably guess what's going to happen here. I'm going to get the x's to be the same, so I'm again going to multiply by 2. My first equation, negative 2x plus 4y equals 1. My second equation is 2x minus 4y equals 6. Here's the opposite. Oh, but here's also an opposite, so I get 0 on this side. 1 plus 6 makes 7. In this case, 0 can never be 7, so we say no solution. Okay, that means the two lines are parallel. And if they have no solution, we call this inconsistent. Now, if it's inconsistent, you don't have to actually say anything else. We just say the system is inconsistent. It's when you say the system is consistent that you also have to give a clarifier as to what type of consistent system it is. Okay, so just kind of be aware of that. I would like you to do the next example on your own in order to get your points for the notes. So this one right here is an on your own. It has to be ready when you come to class to get your points. And you can look at, we gave you tricks in Algebra 2, or you can just flat out solve it. It's kind of up to you. But on your own, 4 notes points. Okay, so let's do that. I just want to kind of keep that, not take the time to do that because I know you can do it in decimal form. The trick is, can you get it out of decimals to make it better? You can look at your book if you need, you can look online, or I think most of you probably already know it. Okay. This next one is our favorite, of course, story problems. And let's talk about story problems. We're going to give you a general look at how do we do this, okay? And so we're going to kind of go through. Now let me give you some background information as well. They're talking about flying from Chicago to Colorado, which is a total of 1,000 miles. We travel into a headwind that is 2 hours and 30 minutes. The return trip with the wind at my back only takes 2 hours. That means it's faster because the wind is pushing me quicker. Find the speed of the plane and the speed of the wind. Okay, there is a question like this in your book. This will come back on the quiz. It will come back on the test. But let me give you some ideas. Let's start first. They use R1 in your book for the speed of the plane. Okay. They use R2 for the speed of your wind. So let's talk about how we can look at these. And these are speeds. Think of speeds in terms of miles per hour, and that might kind of help us go through. Okay, so here we go. If I want to go the faster speed, if the wind is at my back and it's pushing me faster, then we say R1 plus R2 with my wind at back. I'm just going to shorthand this because it's pushing me quicker, which means my speed is going to increase. If I'm going slower, I say R1 minus R2. This is the wind in my face, is the way we kind of talk about it. That means I'm going to go slower. And so as you're looking at this, this is kind of the idea. So we're going to set up 2 equations, one where we say R1 plus R2 and one where we say R1 minus R2. Now, again, these are speeds in miles per hour, so that might help us with the other information we have. So if I do R1 plus R2, that's the wind at my back. Well, I took 2 hours to do 1,000 miles. So when I go through this, I'm going to take 1,000 miles divided by the 2 hours, and I get the mile per hour speed of each of the planes. Then I'm going to do the other one. When the wind is at my face and it takes me longer, I'm taking the 1,000 miles in 2 hours and 30 minutes. This is really 2.5 hours. So divided by 2.5 hours. Okay, and so I'm going to use these two equations. If you think of speed in miles per hour, the setup then isn't that bad. So, okay, let me look at this. I'm going to rewrite these a second. I'm going to go this way, actually. R1 plus R2 is 500 for my first equation. R1 minus R2, 1,000 divided by 2.5. Where did I put that? Is 400. Okay, so here we go. As I look at this, I'm going to go and I'm going to add them now. If you look, I have my opposites. Sorry for the delay. I have my opposites, so I'm going to add them straight down. R1 and R1 means I have 2 of R1. These cancel, equals 900. So when I divide by 2, R1 is 450. If these two together have to add up to 500, then R2 has to equal 50. Now the question is, this is a story problem, what in the heck does this mean? Well, let's look. R1 is the speed of the plane. So the plane travels 450 miles per hour. The wind speed is 50 miles per hour. Okay? And I think, truthfully, setting it up, some other teachers go through this a different way. But when you look at it this way, it's so much easier because you can immediately eliminate if you do the miles per hour setup from the beginning. Okay? And so as you look through, here's what we're talking about. Keep in mind you will have one on your homework and we'll do one on quizzes and tasks, but the plane speed or car speed or anything like that will come back again. So that's it for section 7.2. Again, if you get a chance, start your homework ahead of time.